Adaptive slot allocation method for data link of UAV transmission network. Abstract. In order to avoid under-order data overpaying the data link organization in UAV transmission network for a long time, a more reasonable network slot layout environment should be built. Therefore, an adaptive time slot allocation method for UAV transmission network data link is proposed. In the HFOFD network tempo, the carried interface condition and node interface conditions are solved respectively, and the UAV transmission networking mode is constructed. Then set the dynamic TDMA protocol test and define the expression form of adaptive allocation requirement according to the value range of time slot paraments. The comparison results so that the mixture transmission during of unordered date in the data link organization does not exceed 25 minutes. After the applications of this method, which can promote the maintenance of the recently of the slot layout environment of UAV transmission network. Keywords: UAV transmission network, data link, slot allocation, FHOFDM network template, carrying interface, node interface, TDMN protocol. 1. Introduction. The data link network is used to realize the transmission of data connected by information connection devices such as sensors to the cloud, and it mainly includes two parts, popularly of nodes and a gateway. Among them, the nodes and sensors are connected in one-to-one response so as to ensure that the data connected by the sensors can be aggregated into the gateway through the nodes. In this way, a communication path can be formed between each sensor and the gateway through at least one node. In order to ensure that all nodes can be sent correct responding data to the gateway allocation corresponding time slots for transmission and time slots for reception to notice. The data link adapts a non-central network structure and performance protocol control in a time division mutable access mode, and network members perform message sending and receiving operations based on time squares. In order to give consideration to the principle of fairness and allocation a certain amount of time to each network member, this time division multiple access method evenly cut time along the axis and evenly allocated slot resource with time slots as the basic unit to measurement and time performance as the basic circle. The ultimate goal is to make full, reasonable, and effective use of slot resources, because users will cause a certain delay when they reserve time slots autonomously, which is far greater than the delay of message transmission in the channel. Reducing their time slot reservation delay can be effectively improve the performance of self-organized time division mutable access. In addition to the idle time slot section algorithm, the slot reservation conflict can also directly affect the slot reservation delay of self-organized time division multiple access. UAV transmission network networking mode. The construction of UAV transmission network networking mode is based on FHO-FDM network template and can contain carrying interface conditions and node interface conditions to determine the specific layout of data link organization. This chapter will study the above contents. 2.1 FHO-FDM network template. The FHO-FDM mask for UAV transmission network is developed from multi-carrier modulation. The serial to temporal conversion of data stream makes the symbol period of each subcarrier longer, reduced the inter-symbol interface case by the time dispersion of the wireless channel, and reduced the complexity of accumulation in the receiver. Eliminated the advisor effort of inter-symbol interface. The physical layer application structure of the FHO-FDM network template supports the dynamic allocation of subchannel. In order to enable the physical layer to support asymmetric high-speed data transmission, the OFDM hierarchical structure can allocate different members of subcarrier to achieve different transmission rates in the uplink and downlink. So the FHO-FDM network template is flexible. The data transmission rate can be significantly improved by increasing the number of UAV transmission subcarriers and using high bit rate modulation. However, a priority carrier members and modulation methods should be selected, taking into account the limitations of the actually OFDM system. 2.2 Carrier interface conditions. In UAV transmission network, the channel switcher overhead is much smaller than the time slot length, and the confluence channel services as the control channel and the data transmission channel at the same time. Therefore, the result of the carrier interface condition definition will directly affect the data link organization's carrying complexity for time slot parameters. The Euro frequency hopping transmission is divided into two scenarios. After UAV transceiver completed time synchronization, both parts use the same frequency hopping square at all times. This method is mainly used between the ground station and a single UAV, which has a better antenna interface effect. The default listening channel of the device during the time slot is designated by the local frequency hopping square. The transmitting end randomly switches the channel until the listening channels of the potential receiving end are constant. That is, frequency hopping interselection and condition is established. The transceiver completes the transmission of small load in the same time slot of channel intersection and no longer maintains synchronization in the next time slot. This mode is mainly applied to the secondary user of a congressional radio network. Only the time slot of the next intersection can continue to transmit new data or retransmitted. 2.2 Carrying interface condition. Considering the dynamic change behaviors of data link of UAV transmission network, the time consumed by both communication paths to complete the channel intersection in the worst case will also affect the solution result of the carrier interface condition. The channel hopping square of both communication paths can ensure that when all the channels of the network can become confluence channels with a square period, the diversification of the confluence channels reaches the maximum, which is called complete confluence. Otherwise, it is called particle confluence. 2.3 Node interface conditions. The carrier interface condition can better cope with the internal interface of UAV transmission network. Ensure the concealment of cyber-channel data and the spectrum utilization rate is significantly improved when the devices support multi-part reprojection. Time slot period statics belong to the multi-channel compactive multiple access protocol, which has certain requirements for network equipment. The transmitter supports frequency hopping switching, and each channel is equipped with a receiver, and the transmission and the reproduction can be carried out at the same time. That is a node interface condition. In terms of time resources allocation, carrying sensor conclusion avoidance is enabled on each channel to resolve packet conclusions caused by random frequency hopping. The compactivity access time delay of this access control technology is far less than that is single-channel access, and it can transmit multiple packages on different channels without a mutual interface, and the throughput is also greatly improved. The detailed design of the protocol includes adaptive channel coding rates, priority screening of data packets, active. Data link adaptive time slot allocation processing. On the basis of the UAV transmission network, architecture of the design and applications of data link adaptive slot allocation method are realized according to the processor flow of dynamic TDMA protocol connection. Slot parameter calculation and adaptive allocation demand analysis. 4. Case analysis. In order to highlight the application performance of UAV transmission network data link adaptive slot allocation method, designed in this study, and compare the practical difference between the other convolution network basic link allocation measures, and frequency hopping channel allocation method. The following comparison experiments are designed. 4.1 Incremental environment. Construct UAV transmission network as shown in Figure 3 as the experimental environment. Select WBSN 2400OUN equipment as the basic station element of the body, and HTP GES1 equipment as the data switch element. Connect the basic station element and the data switch with the help of wide area twins pair. After the data sample, output behavior remains stable. Connect the full Parliamental 4 Pro version 2.1 UAV equipment to the transmission network system and record the specific value of relevant environmental data without changing other experimental conditions. 4.2 Result and discussion. Table 1 records the change of the transmission time of an ordered data in UAV transmission network after applying different slot allocation methods. 5. Conclusion. UAV transmission network is increasingly used in military, industry, and other fields. In the unknown and complex work environment, the data transmission interruption of the network system is affected by many factors. When UAV maintains the descent behavior mode, the density of slot nodes is larger, and the UAV multi-hop network faces access difficulty. Due to the high dynamic nature of the topology, the non-adaptive network allocation methods may not be able to cope with the changes in the neighborhood relationship in a short time, especially the concatenated transmission of control information on a single channel, which is easy to case concurrency in the present public control channel. The anti-jamming capability of UAV link is very important to ensure the security of flight control. The internal and external interface of transmission network is the main reason for the limited network capability of flight ad hoc network. Acknowledgement. School-level project of Beijing Polytechnic project named Research on Control System of Multi-Axis and named Area Vehicle with Constant Speed and Variable Pitch.